All right, guys, welcome to my video for the dependent samples t-test. Now, the dependent samples t-test is a different type of test that we're going to focus on. Because when we're doing the dependent samples t-test, we're focusing on one group of individuals at two different periods of time. For our dependent samples t-test, we need to understand the three conditions that allow us to use it. And these are the conditions right here. The second condition is you're looking at the same group of people, the same group of individuals performing in two different activities and subjects, and then you're going to compare the scores together. And finally, when you are using a dependent samples t-test, you are going to be looking at two groups but with matching characteristics, such as the heights of identical twins. The main purpose for our dependent samples t-test is going to be the first condition. We're going to be looking at one group at two different periods of time. In order to determine if there is enough evidence to support our claim, we must follow the 5 steps of hypothesis testing using the traditional method. Step number 1 says state the hypotheses and identify the claim. If you notice, for a dependent samples t-test, our parameter is mu sub d. Remember, for the null hypothesis, the null states that there is no difference. In this case, if there is no difference between the before and after scores for the same group of individuals participating in a study, that means the difference between the scores should be 0. Depending on the direction that we're focused on for our test, we can determine if it's a left-tailed, a right-tailed, or a two-tailed test. All right. After we write our hypotheses, we must find the critical values for our dependent samples t-test. And remember, we know it's a dependent samples t-test because we're comparing a before and an after. Remember, this is still a t-test, so you'll be using the t-distribution to find the critical values. The direction, the level of significance, find your degrees of freedom, and find your critical values. Now remember, if it is a left-tailed, the critical value is negative, and if it's a two-tailed test, the critical value is both positive and negative. Step number 3, which is usually the most complicated step, is to compute the test value. And this is the formula that we're going to use to compute our test value for our dependent samples t-test. T equals to d bar minus mu sub d divided by the standard deviation of the difference divided by the square root of the sample size. The difference of the value is known as d. Now, depending on the direction of the test, you must compute d accordingly. If the test is two-tailed or right-tailed, d is score 1 minus score 2. Usually, score 1 is the before, and score 2 is the after. Write a little bit better. Matter of fact, I want to change something. I want to remove this part right here, and I want to put it over here. Because if the test is one-tailed, if the test is two-tailed, d equals to x1 minus x2. If the test is one-tailed, d equals to x2 minus x1. So put that here. I just realized I made an error right there, but hopefully you guys can catch it. D bar is the average of the difference between scores. So that's the sum of the difference divided by n, which is the sample size. Then you will need to find the standard deviation of the differences in the scores. So that means you must find the sum of D squared. That means you're going to square all the differences and then add it up. Once you have those values, you're going to compute your test value. Step number 4 is to make your decision. We're going to draw the bell-shaped curve and shade the curve. If the test value falls within the shaded area, we reject the null hypothesis. If the test value falls within the non-shaded area, do not reject the null hypothesis. Step number 5 is to summarize the results. If we reject the null hypothesis, we are stating that there is enough evidence to support the claim. But if we do not reject the null hypothesis, there is not enough evidence to support the claim. So we're going to knock out questions 4 and 5 in this video. And both of them are for the dependent samples t-test. And as you can see, we have a before and an after. A dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by a certain mineral. 6 randomly selected subjects were pre-tested and they took the mineral supplement for a 6-week period. The results are shown in the table. Can it be concluded that the cholesterol level has been changed at alpha equals 0.10? Assume the variable is normally distributed. Well, approximately normally distributed. Now remember, the null hypothesis will state that there is no difference between the before and the after. If there's no difference between the before and the after, that means the difference is 0, such that mu sub D, I want to zoom in a little bit. Mu sub D equals to 0. The alternative hypothesis states that there is a difference between the scores, and then we must find the direction of our difference. If we read the question, it says, can it be concluded that cholesterol levels has been changed at alpha equals 0.10? When it is changed, the direction isn't specified. So there's going to be mu sub D does not equal to 0. And that is the claim. Step number 2 is to find the critical values. We know that this is a dependent samples t-test because we're looking at a before and an after. The direction is two-tailed because the change is not specified a direction. Two-tailed. The alpha is 0.10. And because this is still a t-test, you must find your degrees of freedom. I have 6 subjects, so my degrees of freedom will be 5. Remember, because this is a two-tailed test, the critical value will be positive and negative. On our t-distribution, the degrees of freedom is 5. A two-tailed alpha is 0.10. And that value is going to be 2.015. Therefore, the critical values will be negative 2.015 and positive 2.015. Step number 3 is to compute the test value. But in order for us to compute the test value, we need to find D bar and S sub D. And remember, this is a two-tailed test. So to find D, it is x1 minus x2. Mu sub D already is equal to 0 because it is stated right up here for the null hypothesis. And the sample size is 6. We have 6 individuals. So let's compute our D, which is the difference. X1 minus X2, before minus after. So if we subtract here, this is 210 minus 190. Let's do this in red. 210 minus 190. That's going to equal to 20. The next one is 235 minus 170. That is 65. Continue the same pattern. 208 minus 210 is negative 2. 190 minus 188 is positive 2. 172 minus 173 is negative 1. 244 minus 244 minus 228, that is positive 16. To find the sum of our difference, we're going to add up all of the D's and keep the signs, respect our signs. So 20 plus 65 plus negative 2 plus positive 2 plus negative 1 plus 16, that equals to 100. Because we found the sum of D, let's go ahead and find D bar first. The D bar equals to the sum of D divided by N. So that's going to be 100 divided by 6. And let's take 3 numbers after the decimal. So 100 divided by 6, that is 16.667. Now we have to find the standard deviation for our difference. So we must square all of our D's and then add them up. The first D is 20. So if I square 20, that is going to be 400. The second D is 65. So when I square 65, that's going to add up. So what it's going to equal to 4,225. Remember, when you square a negative number, it comes out as positive, and you must put the negative in parentheses before you square it. 2 squared is 4. Negative 1 being squared is positive 1. And 16 being squared is going to be 256. To find the sum of D squared, you're going to add up all the values in blue. And that's going to equal to 4,890. Now we can find the standard deviation. That's going to be the square root of N, which is 6, times the sum of D squared, which is 4,890, minus the sum of D. The sum of D is 100, but you're squaring that. And that's divided by N, which is 6, times N minus 1. So 6 minus 1. $29,340. When you square 100, that is 10,000. And the bottom is just going to be 30. Because this is 5. 6 times 5 is 30. If you subtract the tops, that is 19,340 divided by 30. Under the square root, that is 644.667. I'm taking 3 numbers after the decimal. And then let's take the square root of 644.667. Take 3 numbers after the decimal, which is 25.390. Now that we have the standard deviation and the sample mean, we can compute the test value. T is equal to D bar, which is 16.667, minus mu sub D, which is 0, divided by the standard deviation of our difference, which is 25.390, divided by the square root of the sample size, so square root of 6. So the top is 16.667. The bottom, let's do that and take 3 numbers after the decimal. Square root of 6. That's 10.365. Let's divide that. Take 3 numbers after the decimal again. So that is going to be T is approximately 1.608. And that is the test value. Step number 4 is to make the decision. So we're going to draw the bell-shaped curve to the best of our abilities, of course, and place the critical values on the bell-shaped curve. So on the left side, the critical value is going to be negative 2.015. And on the right side, that's going to be positive 2.015. And then we're going to shade into the tail regions. Now remember, if the test value falls within the shaded or the highlighted areas in this case, we're going to reject the null hypothesis, which means there is evidence to support our claim. However, if the test value does not land within the shaded area, do not reject the null hypothesis, which means there is not enough evidence to support the claim. 1.608 will fall on the right side, but not within the highlighted area. It will fall, let's say, right there. And because it falls outside of the highlighted area, we do not reject the null hypothesis. So that means if we are not rejecting the null hypothesis, we're going to accept it for what it is. And if you notice, we took the statement that is not our claim, which means there is not enough evidence to support the claim. There is not enough evidence to support the claim that a diet supplemented with a certain mineral can change cholesterol levels. Okay, let's do the next one. It says a dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by a certain mineral. 6 randomly selected subjects were pre-tested, and then they took the mineral supplement for a 6-week period. The results are shown in the table. Can it be concluded that cholesterol levels is lower after taking the mineral at alpha equals 0.05? Assume the variable is approximately normally distributed. So once again, the null hypothesis will state that there is no difference between the before and the after cholesterol levels. Mu sub D equals to 0. Because if there's no difference, that means the difference is 0. In this case, we're looking to lower the cholesterol levels. Lower indicates a left tail test. Therefore, mu sub D is less than 0. And that is the claim that we're trying to find evidence to support. We know it's a dependent samples t-test. And we know it is a left tail test. The alpha is 0.05. My degrees of freedom, I have 6 subjects. So 6 minus 1 is 5. Because it is a left tail test, we know the critical value must be negative. So we're going to go to the t distribution. This is a one tail test. Alpha is 0.05. The degrees of freedom is 5. And if you notice, the number is going to be 2.015. Kind of like the last one, except this is one-tailed and it is to the left. Therefore, the critical value is negative 2.015. You want to compute your test value. Because it is a left tail test, which is a one tail test to the left, D is x of 2 minus x of 1. Subtract in the order. Mu sub D is 0, once again, because of the hypotheses. And the sample size is 6. So now we need to find D bar. Once again, we're subtracting x of 2 minus x of 1. 190 minus 210. 170 minus 256. 210 minus 250. So on and so forth. 190 minus 210 is negative 20. 170 minus 256 is negative 86. 210 minus 250, that is negative 40. 180 minus 199 is negative 19. 173 minus 172 is positive 1. 200 minus 244, that is negative 44. You're going to add these differences together to get the sum of your difference. And as we can see, that is going to be negative 208. So with that said, let's find the sum of D. Well, sorry, let's find D bar, which is the sum of D divided by the sample size. That's going to equal to negative 208 divided by the sample size, which is 6. Divide that by 6. And we get negative 34.667. Okay. Now we need to find D squared. So we're going to square all of these values. And remember, when you square a negative number, it comes out as positive. For example, when you square negative 20, we get positive 400. When you square negative 86, it's going to come out as positive. Oops. Look at me. I should have deleted this. 7396. So when you square negative 40, that's 1600. When you square negative 19, that's 361. When you square 1, well, that's just 1. And when you square 44, you get 1936. Let's add those together. 11,694. So now we can find the standard deviation. Okay, let's multiply the 6 with the 11,694. That is 70,164. Minus, we're going to square negative 208. Remember, when you square a negative number, it comes out as positive. So that's going to be 43,264. The bottom's just 30. Let's divide that number by 30. Square root of 896 point, what happened here? 896.667, that's 29.944. Now we have everything that we need to compute the test value. T is equal to negative 34.667 minus mu sub d, which is 0, divided by the standard deviation, which is 29.944. And that's divided by the square root of the sample size. So the square root of 6. The top will remain the same, negative 34.667. The bottom, 29.944 divided by the square root of 6. That is going to be 12.225, because that 4 makes that 5. So that 5 right there will make that 4 round up to a 5, excuse me. And negative 34.667 divided by 12.225. Let's take 3 numbers after the decimal. Negative 2.836. Step number 4 is to make your decision. Draw the bell-shaped curve. This is a left tail test, and the critical value is negative 2.015. Okay. Now you're going to see where the test value, negative 2.836, will fall at. Negative 2.836 will fall over here. It is more negative than negative 2.015. And because it falls in the shaded area, we're going to reject the null hypothesis. So we are rejecting the null hypothesis, which means we have to take the claim. There is enough evidence to support our claim. All right, guys, that is it to the video. Hope you understand how to perform your dependent samples t-test. And I'll catch you in the next video. Take care.